Hello guys, welcome to H2O, the A to Z of chemistry. I am Dr. Ritu Johar, your educator for this course, Some Basic Concepts of Chemistry. Today we will begin with lecture 4 from this course, but make sure you have watched the previous 3 before viewing this one. In this lecture, we would be discussing the laws of chemical combination. So what are the laws of chemical combination? So they are the laws governing the combining of elements to form compounds, and general rules were formulated based on quantitative experiments performed by various scientists. So the scientists, they did quantitative experiments on the reactions where the elements were combining to form compounds, and then they saw that they could make certain generalizations in these reactions, and these generalizations are what we call as the law of chemical combination. We have 6 such laws. The first one is the law of conservation of mass by Antoine Lavoisier, law of definite or constant proportions by Joseph Proust, law of multiple proportions by John Dalton, law of reciprocal proportions by Richter, Gay-Lussac's law of gaseous volumes, and the Avogadro's law. So please do remember the name of the scientists also who have given these laws along with the law, because they are mentioned in the NCERT textbook, and everything in the NCERT textbook is really very important for you for any sort of competitive exam. Now in this lecture, we would be discussing the first 4 laws, and the next 2 we would be discussing in the next lecture. So the first law we have is the law of conservation of mass, this being given by Antoine Lavoisier in the year 1789. This computes the relationship between the mass of the reactants and the products in a chemical reaction. And this law states that matter can neither be created nor destroyed during any chemical change. In simple words, we can say that it is the total mass of the reactants before the reaction is equal to the total mass of the products after the reaction. That means that the mass is conserved. Right? So whatever is the mass of the reactants, if you calculate what is the mass of the products, that is going to remain the same. This law can also be called as the law of constancy of mass, the mass being constant. Fine. In example, we can understand this by conversion of ice into water. So when we convert ice into water, there is no mass change. For example, if you take 5 grams of ice, melt it down to water and weigh the mass of water, it is also going to be 5 grams. So there is no mass change. This is a physical change. You can even understand this with a chemical change also. That is also going to be exactly the same. If you weigh the reactants and then after the completion of the reactants weigh the mass of the products, that is going to be the same. Now we have one limitation to this law. And what is that limitation? Well, the limitation is that in a number of reactions, especially the nuclear reactions, they involve a mass change. And what happens to that mass? That is converted into energy. In a nuclear reaction, there is a tremendous release of energy, right? We studied about the nuclear reactions also. So in a nuclear reaction, the reactant mass is getting converted, some portion of it, into energy. In a chemical reaction also, it does happen that a portion of the mass is getting converted into energy, but that change is not that appreciable, right? Now, this conversion of mass into energy is in accordance with the Einstein's theory of relativity, which states that the mass and energy, they are interconvertible in accordance with the equation E is equal to mc square, where c is the velocity of light, that is 3 into 10 power 8 meter per second. So we had to modify the law of conservation of mass. And the modified law says that the mass and energy, they are interconvertible, and the total sum of mass and energy during any physical or chemical change remains constant. Fine. So let us understand now the law of conservation of mass with a few examples. So the first numerical says that when 4.2 gram of sodium bicarbonate is added to a solution of acetic acid, CH3COOH is acetic acid, this weighing 10 grams, it is observed that 2.2 gram of carbon dioxide is released into the atmosphere. The residue left is found to weigh 12 gram and show that these observations are in agreement with the law of conservation of mass. Now we have the reactants, sodium bicarbonate and acetic acid, and we calculate the total mass of the reactants. Okay, and then we see carbon dioxide and a residue in the product side, and then we will add the mass of the products and see whether they are equal. Now in the reaction, what is happening is that sodium bicarbonate and acetic acid, they are combining to form sodium acetate plus water plus carbon dioxide, right? So the total mass of the reactants 4.2 plus 10 is 14.2 gram, and total mass of the products 2.2 of the carbon dioxide and 12 of the residue. The residue was sodium acetate plus water. So this also comes up to 14.2. Hence the mass of the reactants is equal to the mass of the product, and the reaction is in accordance with the law of conservation of mass. Fine. So now we can see one more numerical on it. These numericals, they are going to really help you understand all these laws very well. So we have 0.66 gram of a compound containing carbon and hydrogen on complete combustion with oxygen. This gave 2.7 gram of water and 1.32 gram of carbon dioxide, and we have to show that the data illustrates the law of conservation of mass. So we have carbon and hydrogen total weight before the reaction 0.66 gram. And what does this compound on combustion with oxygen give? Carbon dioxide and water. So what we are supposed to do is that we are to see the total weight of carbon and hydrogen after the reaction, and when we have found that, we can just simply total that and see whether it is equal to the carbon and hydrogen weight before the reaction. Fine. So now the molecular weight of carbon dioxide is 44 AMU. Okay, so 12 of carbon and 32 of oxygen. 12 plus 32 is 44 AMU. So 44 gram of carbon dioxide, the gram molecular weight, so is going to be having carbon 12 grams and 1.32 gram of carbon dioxide. This is given to us. So we'll have how much carbon? 12 divided by 44 into 1.32, simple unitary method. So 0.36 gram. And the molecular weight of water is 18 AMU. So 18 gram of water will have how much hydrogen? 2 gram. And 2.7 gram of water, which is given to us, is going to have how much hydrogen? 0.30 gram. Now add the weight of carbon and hydrogen after the reaction, 0.36 and 0.30, 0.66. Now this is equal before the reaction. So hence we can say that the data illustrates the law of conservation of mass. I hope it is clear to you all. So now we have the law of definite proportions or constant proportions. This was given by Joseph Proust. And what does this law say? It says that a pure chemical compound, regardless of its source, is always made up of the same elements combined together in the same fixed proportion by weight. So whatever may be the source of the chemical compound is made up of the same elements, and the same elements, they have the same proportion also by weight. Fine. For example, we have water. So you take water from any source, be it a sea, ocean, river, pond, or the tap water. So water is going to be made up of hydrogen and oxygen combined in the ratio of 1:8 by weight. Why? Because H2O, so 2 hydrogen 2 gram, 1 oxygen 16. So 2:16 is 1:8. So regardless of the source, water is going to composed of hydrogen and oxygen by the weight of 1:8, and this is what the law of definite proportion say. So let us see numerical based on this also. So we have a numerical saying that 1.375 gram of copper oxide gave 1.098 gram of copper when reduced in a current of hydrogen. In another experiment, 1.476 gram of cupric oxide gave 1.79 gram of copper on reduction. Show that these results, they are in agreement with the law of definite proportion. Fine. So now, either it is given cupric oxide or copper oxide, it is basically one and the same thing, because if we have to explain the law of definite proportion, the compound is the same, right? So we have to just, we have a different source of the compound, okay? Now, we will see that what is the ratio or percentage of copper and oxygen in one compound, and compare with the ratio or percentage of oxygen and copper in the second compound. And if this percentages are same, that means that the law is explained. Fine. So in the first experiment, the weight of copper oxide taken is 1.375 gram. The percentage of copper would be how much? 1.098, which is given to us. Okay, and divided by 1.375 into 100, this comes to be 79.86%, and percentage of oxygen is going to be 100 minus the percentage of copper, so this comes to 20.14%. Similarly, in the second experiment, the weight of copper oxide is 1.476 gram. So the percentage of copper would be 1.179 divided by 1.476 into 100. So this comes up to 79.89%. And oxygen is 20.11%. So the percentage of copper is almost the same in the two, percentage of oxygen is almost same in the two, hence the results are in agreement with the law of definite proportions. So now we have another example for it. So here what we are going to see is that there is a sample of pure calcium carbonate, and this was found to contain 40% calcium, 12% carbon and 48% oxygen. And if the law of constant composition is true, then we have to find the weight of calcium, carbon and oxygen in 5 gram of another sample of calcium carbonate. So we have calcium carbonate, the compound is the same, so the percentage of the elements has to be the same, right? So now in this 5 gram, we will find out what is the percentage of each element. That is going to be the same. So calcium also 40%, carbon also 12% and oxygen also 48%. So the weight of calcium in the sample is 40% of 5. It is going to be 2 gram. Weight of carbon is going to be 12% of 5.6 gram. And weight of oxygen 48% of 5. 2.4 gram. So this has helped us in finding the weight of the individual elements in another sample of calcium carbonate, just this being simplified to us by the law of constant proportions. Fine. So now we have the third law, which is the law of multiple proportion, and this was given by John Dalton. And what does this law say? This says that if two elements, they combine to form more than one compound, the masses of one element that combine with the fixed mass of the other bear a simple ratio to one another. Let us understand this with an example, then you will be able to appreciate it. So we have carbon and oxygen. They are combining to form carbon monoxide and carbon dioxide. Okay. So we have two elements, they are combining to form more than one compound. Now what are we supposed to do? We are supposed to see the masses of one element, which we can say that is oxygen, this combining with the fixed mass of the other. The fixed mass of the other, let it be of carbon. Okay. So the ratio of masses of carbon and oxygen in the two compounds. First we have carbon monoxide. So one atom of carbon and one of oxygen, so it is 12:16. Whereas in carbon dioxide, we have one carbon and two oxygen atoms, so the ratio is 12:32. So we have to fix the mass of one element. So here carbon is already 12, the same mass in both the elements. Now what we do is we see the ratio of the oxygen which is combining with the fixed mass of carbon, which is 16:32. So now this is again a simple ratio because 16:32 is 1:2. Fine. So this is what the law of multiple proportions say, that if there are two elements, they combine to form more than one compound, and you fix the mass of one and see the ratio of the masses of the other element, they are going to have a simple ratio to one another, right? We can see one more example to it. We have nitrogen and oxygen. So here nitrogen and oxygen, they combine to form 5 different compounds: nitrous oxide N2O, nitric oxide NO, nitrogen trioxide N2O3, nitrogen dioxide NO2, and nitrogen pentoxide N2O5. What we are going to do is we are going to fix the weight of one. Let it be nitrogen because nitrogen is 2 or 1 atom in all the 5 compounds. And then we will see what is the ratio of the oxygen combining with that fixed mass of nitrogen, right? So in nitrous oxide, the ratio of nitrogen is to oxygen is 28:16. In nitric oxide, it is 14:16. We'll convert it into 28. So 28:32. Then nitrogen trioxide 28:48, nitrogen dioxide 14:32, make it 28:64, and N2O5 28:80. So all nitrogen fixed at 28 grams. And now you see the ratio of oxygen is 16:32:48:64:80, which comes simple terms to 1:2:3:4:5. And this is what is the law of multiple proportion. Now we can apply this law to our numerical. So we have carbon and oxygen. They are known to form 2 compounds, and the carbon content in one of these is 42.9%, while in the other it is 27.3%, and show that the data is in accordance with the law of multiple proportions, right? So what we are going to do, we are going to fix the weight of carbon and see how much oxygen is combining with that fixed weight of carbon. In the first compound, we have weight of carbon. Because it is 42.9%, we can say that it is 42.9 gram, and oxygen would be 100 minus that 42.9, so 57.1 gram. Now, as 42.9 gram of oxygen is combining with oxygen 57.1 gram, 1 gram of carbon combines with oxygen how much? 1.331 gram. So, fix the weight of carbon to be 1 gram. Right? Then we have carbon in the second compound to be 27.3 gram. The weight of oxygen would be 72.7 gram. So if 27.3 gram of carbon is combining with oxygen 72.7 gram, 1 gram of carbon will combine with how much oxygen? 2.662 gram. Now see the ratio of 1.331 is to 2.662. This comes up to 1:2, a simple whole number ratio. Hence the data is in accordance with the law of multiple proportions. So the next law, this is also a very interesting law. So we have, so we have the law of reciprocal or the equivalent proportion. And what does this law say? It states that the ratio between the masses of the two elements A and B, which combine with the fixed mass of the third element C, will be same or the simple multiple of the ratio in which the elements A and B combine together. So this is a bit confusing. Don't worry. Let us see it again. So the ratio between the masses of two elements A and B. So we have assumed that we have two elements A and B. One is hydrogen and B is oxygen. So they have to combine with the fixed mass of the third element C. Let the third element C be sulphur. So the compound of hydrogen with sulphur is H2S, and the compound of oxygen with sulphur is sulfur dioxide. So now we fix the weight of sulfur and see what is the ratio of hydrogen and oxygen combining with that sulfur, right? So A with C, H with S in H2S is 2 is to 32, and B with C, that is O with sulfur, sulfur dioxide is 32 is to 32. So now already the weight of sulfur is the same in both the compounds. If it is in any question of yours not the same, you will have to make it same. So here, because the weight of sulfur is fixed, we simply see the ratio of hydrogen and oxygen combining with the fixed weight of sulfur. So 2 is to 32 is 1 is to 16, right? So now what the law says is that this ratio 1 is to 16 will be same or a simple multiple of the ratio in which the elements A and B combine together. Now A and B combine together to form water, right? So what is going to be the ratio of hydrogen and oxygen in water? That is 2 is to 16 or 1 is to 8, right? Now you compare the two ratios. They are not equal, but they are a simple multiple of each other, right? So 1 is to 16 is to 1 is to 8, 1 is to 2, a simple ratio. Hence this is the law of reciprocal proportion. What it says, you take two elements A and B, combine with the fixed weight of the third element C, right? And whatever ratio is coming, compare that ratio with the ratio between the element A and B. That is going to be same or a simple multiple. So we have a numerical to apply this law also. And what does the numerical say? So H2S is containing 94.11% sulfur, water contains 11.11% hydrogen, and sulfur dioxide contains 50% oxygen, and you have to show that the results are in agreement with the law of reciprocal proportion, right? So we have water and we have sulfur dioxide. What is common in both of them? Oxygen, right? So what we will do is we will fix the weight of oxygen and then see what is the ratio of hydrogen into and sulfur. So weight of hydrogen according to the data is 11.11%. So this is 11.11 gram, and weight of oxygen would be 100 minus this 11.11. So 88.89%. In sulfur dioxide, because we had 50% oxygen, so 50% is sulfur. So 50 gram sulfur and 50 gram oxygen. Now what we will do is we will convert this 50 gram of oxygen into 88.89 gram oxygen, right? So what was the weight of sulfur which is going to combine with 88.89 gram of oxygen? It is also going to be 88.89 gram of sulfur. So this is all simple mathematics. I am not teaching you anything over here. So that is why I told in the start of the course also that what you need is just an understanding of your elementary maths. So now see the ratio of sulfur and hydrogen. So sulfur is 88.89 and hydrogen is 11.19, which is combining with the fixed mass of oxygen, which is 88.89 gram. So the ratio comes to 8 is to 1. Now in H2S, we see the ratio of sulfur and hydrogen. So sulfur is 94.11 and hydrogen is 5.89 gram. So the ratio, this comes to 16 is to 1. So compare the two ratios, 8 is to 1 is to 16 is to 1. So this is 1 is to 2, a simple ratio. Hence, the results are in agreement with the law of reciprocal proportions. So this brings me to the end of this lecture. We have completed 4 laws. The remaining 2 we would be doing in the next lecture. So we will meet in the next lecture on laws of chemical combination 2. In case you have any problem in understanding anything, you have your comments, you have your suggestions to give to us, or any problem to ask us further about this course or this lecture, you can mail us at h2ochemistry@gmail.com. If you have liked the lecture, please do upvote for it, and if you're liking the course, please do subscribe to it, because only then you're going to receive a notification as and when I put up a new lecture for this course. So see you again in lecture number 5. Have a nice day. Enjoy yourself.